My name is Christina Chin. I'm a senior at Cornell University, and I spent the summer as an Arnott intern researching the effects of Marcellus Shale gas infrastructure on amphibians and reptiles of Northeast forests. I'd like to thank Christy and Steve for being my advisors throughout my project, and also Casey, Gary, Peter, Kathy, Cassie, Tanya, and Devin for helping me throughout my project. So an overview of my project. There is currently major activity of Marcellus Shale gas development in Pennsylvania. There are 60,000 new Marcellus wells that are projected by 2030 in Pennsylvania, and currently 3,693 producing wells. The picture, or the map on the screen, is of existing and projected Marcellus Shale natural gas wells. So natural gas infrastructure has a lot of effects on forests. Well pads and many miles of pipeline are put through or are installed through forested areas, causing loss of forest habitat and fragmentation in remaining forests. Forest clearing projections in Pennsylvania are 38,000 to 90,000 acres for well pads and an additional 60,000 to 150 acres for pipelines. There's a projected range of 6,000 to 15,000 new well pads in Pennsylvania by 2030. And the picture shows 2 large well pads with pipelines cutting through the forest. Here's a closer look at what infrastructure looks like. So this picture of a well pad on the left is one of my study sites, and the pipeline is a picture of a pipeline, a natural gas pipeline just cutting through a forest. As you can see, large swaths of land are deforested to install well pads and to lay down pipeline. So the effects of fragmentation from well pads and pipelines include increases in light and temperature, decreases in soil moisture and habitat quality, and increases in invasive species and pests. And there are currently over 305 miles of 305,000 miles of pipeline in the U.S. So the organisms I decided to use for my project were salamanders because they're a wonderful proxy for ground-dwelling and fossorial organisms, and they're very sensitive to environmental changes, such as temperature, moisture, and cover. And red-backed salamanders are the most abundant vertebrate in northeastern forests, which makes them great for data collection. We also decided to use snakes as a proxy for other measures of biodiversity that salamanders don't cover, because they can tolerate higher temperatures, but they're also sensitive to cover and temperature. So my objective of the study was to identify and quantify effects of natural gas pipeline forest fragmentation on populations of amphibians and reptiles. There are 2 main points of my study. On the pipeline itself that runs through the forest, that cuts through it, I wanted to know if organisms use the pipeline opening, and if so, is there a relationship to temperature effects? And also, can piles of woody material mitigate fragmentation and offer animal refuge? And secondly, I wanted to look at the effects into the adjacent forest. So do pipeline effects extend into the adjacent forest? And if there's is there a difference in temperature and light versus distance from the pipeline? And what are the associated effects on organisms? My study sites were in northern Pennsylvania and rural and forested landscapes. You can see on the map where they were located in Potter and Susquehanna counties. And the picture is of Horton Run, one of my study sites. So you can see what kind of site or what kind of forest we were working in. So on the pipeline itself, we had piles of woody material that were about 4 to 5 feet tall versus open sites to compare if this woody material could mitigate any factors for animals. You can see on the bottom right corner, there are piles here, and then and we had open sites as well. So we used cover boards for salamanders, cover sheets for snakes, and temperature loggers for measuring temperature on the pipeline. A closer look at what the pipeline diagram was. So here are the forest edges of the forest. The pipeline runs vertically throughout the forest. And as you can see, there are pile sites and open sites. Around each of the two different sites, we had cover boards and cover sheets. The cover boards were, again, used for salamanders, and the cover sheets were used for snakes. And we had the exact same setup mirrored in the open sites so that we could study the differences of animals between the two sites. And within each site, we also had temperature loggers. So we would have a temperature logger in open and a temperature logger in a pile. So this is what a cover board looks like for salamanders, and this is what a cover sheet looks like for snakes. So into the adjacent forest was the second part of my objective I would like to study. Here's the pipeline, and we had perpendicular transects, two different transects that ran perpendicularly into the forest. We had 100-meter transects for natural cover and 50-meter transects for cover board and temperature measurements. So a natural cover search involved turning over every rock that was greater or equal to 10 centimeters in width, and every stick that was greater or equal to 2 centimeters in width within a 100-meter long transect and a 3-meter wide swath. And right here you can see the swath there, which measured out 3 meters, and we would go along a 100-meter transect. For cover boards, we placed cover boards every 10 meters from 0 to 50 meters along a transect that ran perpendicularly into the forest. We also deployed temperature and light loggers every 10 meters from 0 to 50 meters as well. So salamander abundance on the pipeline. So we found that more salamanders were near piles than open. And this is the mean redback salamanders per board. And as you can see, the mean per board is much higher near a pile than near an open site. So snake abundance on the pipeline. I'd like to explain this diagram first. We just basically took away all the cover board positions, and what we have left are the cover sheets on this diagram. So this red corresponds to position 1 right here, and position 1 is closest to the forest, closest to the forest edge right here and right here. Those are the edges of the forest, and there's another position 1 on each side. Position 2 is getting closer to the middle, and position 3 is the middle of the pipeline. So the position of cover, snakes were only found near the forest edge in 2012. This was possibly explained because it was a hotter climate in 2012, and in 2013 there was no significant difference in the position that snakes were found on this pipeline. So here's a scatter plot of temperature on the actual pipeline. The black dots are open and the red dots are pile sites. And as you can see, piles are significantly cooler than open areas. The results of salamander abundance into the forest from natural cover transects shows that the number of redback salamanders increases significantly from pipeline edge into the forest. So this is the distance into the forest from the transect 0 to 100 meters, and this is the number of redback salamanders. And as you can see, this regression line, this blue regression line right here, shows the trend, the upward trend as we enter the forest, the upward trend of salamander abundance. Another graphical example was the coverboard transect from 0 to 50 meters. As you can see, the trend is also reflected, and there is an increase of salamander abundance into the forest. However, I wanted to point out that the mean redback salamanders on the pipeline only reach to right here, 0.034 salamanders per board. But as we enter and go further in distance into the forest, it rises much higher. So it reflects the significant increase in salamander abundance from the natural cover transect. Here we measured light into the forest, and so we found that light significantly decreased as we entered into the adjacent forest, and so did temperature. So it got cooler as we went further into the forest, significantly. So here are the 3 sites of mean noon temperatures, just a graphical example of what we just saw. For all 3 sites, you can see that, if it'll show up, there it is. So you can see that temperature decreases significantly for all sites. Between 0 and 10 meters, it's very obvious as well. But the important part about this I wanted to point out was the mean critical maximum temperature. So a temperature that the maximum temperature that a redback salamander could handle is 34.6 degrees Celsius. And on the pipeline at 0 meters, at the edge of the forest, it reaches temperatures above the critical maximum temperature for redback salamanders. And since this is a mean, there could be a maximum temperature above this critical temperature that isn't shown for each of the sites. Another redback temperature threshold is the energy deficit threshold at 20 degrees Celsius. This is when a redback salamander loses more energy because it's too hot than it is able to gain. And I wanted to recall the scatter plot of temperatures on the pipeline, and I placed the 2 thresholds on the scatter plot as well. So as you can see, open sites rarely go below the 20 degrees Celsius energy deficit temperature, while pile sites never go above this 34 degrees or 34.6 degrees critical maximum temperature for redbacks. So this is where pile sites stayed, while open sites rarely went below 20 degrees. So in conclusion, on the pipeline, temperature significantly was higher in open areas. And there's a strong trend between salamanders and piles. Open areas may become too harsh for salamanders this way, and that's why they may choose piles. When it's hot, snakes tend to favor forest edge cover sheet positions. Positions further from the forest edge may also become too harsh for snakes. And for transects from the pipeline into the adjacent forest, there's a significant decrease in temperature and light and significant increase in salamanders. So recommendations for temperature and moisture. Since piles reduce temperatures to below the critical maximum temperature for redback salamanders, I'd suggest to put more cover on the pipeline to decrease temperature fluctuations and increase moisture retention. Additionally, in terms of animal refuge, additional piles or scattered woody material could increase the benefits for animals, and additional shrub or vegetative cover could increase the benefits as well. Thank you.